Here we have a statistics question taken from the 2018 applied maths paper from the AS Maths selection. So we've got 7 marks available in total, and it's a mixture of binomial probabilities and hypothesis testing. So Nazir is playing a game with 2 friends. The game is designed to be a game of chance so that the probability of Nazir winning each game is 1/3. Nazir and his friends played the game 15 times, and we are to find the probability that Nazir wins exactly 2 games and then more than 5 games for the first 3 marks of this question. Then Nazir claims he has a method to help him win more than 1/3 of the games. To test this claim, the 3 of them played the game again 32 times and Nazir won 16 of these games. Stating your hypothesis clearly, test Nazir's claim at the 5% level of significance for the remaining 4 marks in this question. Okay, so part A. So I've got 15 trials and a probability of success in each trial being 1/3, and that tells me that I have binomial probabilities to calculate. I have an n and a p. So I can call my random variable x, which will be the number of successes when Nazir plays this game 15 times. So it's binomially distributed, n is 15 and p is 1/3. And the first part of the question wants me to calculate the probability that my random variable capital X takes on the value 2. Okay, there's 2 ways to do this. We can use the formula booklet. So if I show you the formula booklet here, I'm on page 23 in the statistics section of the Edexcel formula booklet. And you can see here I've got some discrete distributions. And at the top, I've got my binomial with my number of trials and probability of success P. And then in this column, I can see the probability that my random variable, capital X, takes on the value little x. And I'll find that probability by plugging my values into that formula. Or you can use the function on your calculator. So it's not more than or equal to 2 or less than or equal to 2, it's just equal to 2. So I need a probability density function. So over to the calculator. So press in menu. And I'm going over to my distribution function. I can see I've got some normal probabilities, which we're not interested in, but there's binomial probability density. And then in the next list, we've got binomial cumulative distribution, which we'll be using in a second. But for now, just want the probability that my random variable is equal to 2. So I need binomial probability density. So I'm going to push 4. And I'm going to put my variables in. So little x being equal to 2 is what I'm after. When my number of trials is 15. And the probability of success is 1/3. So what's that? 0.599 to 4 decimal places. So probability that capital X equals 2 is 0.0599. To 4 decimal places. Okay, so the next part, so not too bad. Nice and easy, single probability to calculate. And the second part of part A asks us to find the probability that the random variable capital X is more than or equal to, just more than 5. So probability capital X is more than 5. So this is the probability that it's more than or equal to 6, right? So I can have 6, 7, 8, 9, all the way up to 15. But when we're using the function on the calculator or the tables in the formula booklet, we are looking for probabilities that are less than or equal to. So I need to change this first of all. So I'm going to do 1 minus the probability that it is less than or equal to 5. So 6, 7, 8, 9, 10 upwards to 15 doesn't include 0, 1, 2, 3, 4 or 5. So what I need to do is use my button on the calculator or the formula booklet to find out the probability that my random variable is less than or equal to 5 first of all. So let me just show you in the formula booklet. Now, you can't always use the formula booklet. But if we see here, we've got a binomial cumulative distribution function, which is what we want because we've got the less than or equal to probabilities to calculate. However, these are our probability of successes up here. Let's just do that in highlighter. Probability of successes here with number of trials down here, which we do have 15 for the number of trials, but we don't have probability of success being a third available to us. So we can't use the formula booklet for this one. So instead we go back to the calculator. So this time what I'm going to do, go back to my menu. I press 7 again, so I'm in my distributions. I don't want probability density, I want cumulative distribution this time. So press 1 on that list and then variable. Now I need to find the probability that I'm less than or equal to 5. So let's change that to 5. I still have 15 trials with a probability of success of a third. So that's the probability I want. 0.6184 to 4 decimal places. So back over here, so 1 minus 0.6184, and if I plug that in the calculator, so coming out of your distributions back to the calculator function, which I can show you in a second, 1 minus 0.6184, my probability is 0.3816. Okay, so just to show you how to come out of the distribution function. So here we were, so this is where we were, where were we? We were in here, calculating probabilities in here. Just press this menu button again, and to go back to calculator you can press 1 or scroll across and press equals on calculate, okay? So that's part A complete for the 3 marks. So we've done our single probability and then our cumulative probabilities. And in part B, we need to do this hypothesis test. So Nazir thinks he's got a way to win more than 1/3 of the games. And then we need to test this claim by doing an experiment, which is usually what we do in hypothesis testing. But the first thing we do for a hypothesis test is state our null hypothesis and our alternate hypothesis. But we have a statistic first of all. So P is our probability of success. Yes, i.e. winning a game. Okay, now before Nazir makes this claim that the probability could be more than 1/3, the norm is that probability of winning is 1/3. And that's the null hypothesis. And then he presents this alternate hypothesis where this probability could be more than 1/3. Okay, and then what we do to test this claim is to have an experiment. So the experiment here is that they play the game again 32 times, and the outcome of that experiment is that he wins 16 of them. So what we need to do is find the probability that he wins 16 or more of these games out of the 32 by chance. Now we're told the level of significance is 5%. So we need to find the probability of the outcome of this experiment. If the probability is less than 5%, it's unlikely that this happened by chance. So his claim could possibly be true. So that means we have evidence to suggest that we might reject the null hypothesis, the original one. So let's find out the probability of getting 16 successes out of 32. So, new random variable capital X, which is now binomially distributed with 32 trials, probability of success being a third under the null condition. So for now, we're just assuming the original criteria. Now, the outcome of this experiment is 16. So little x is 16. Now, I need to find the probability that my random variable is greater than or equal to 16. Not just equal to 16, because if you get 16 successes, or 17, or 18, or 19, and so on, that would suggest that there is a higher chance of being successful in this game, or the probability is higher than a third. So not just 16. So what is the probability that my random variable is greater than or equal to 16? Well, it's 1 minus the probability that it's less than or equal to 15. So this is what I need to do. I need to find the probability that my random variable is less than or equal to 15. So back over to the calculator, go to my distribution function. This one is cumulative again. So set my variables. Little x being 15. Number of trials now being 32. And the original assumption is that the probability of success is a third. So the probability for being less than or equal to 15 is 0.9623 to 4 decimal places. So 1 minus 0.9623 is equal to, so come out of your distribution, back to your calculator, 1 minus 0.9623 is 0.0377. Okay, if we remember, our significance level was 5%, which is 0.05. This probability here is less than 0.05. Right. So what are we saying here? We're saying that the probability of getting 16 or more successes when the number of trials is 32 and the probability of success is a third is lower than 5%. So the probability that this happens by chance under the null assumptions is so low that it's unlikely that those null assumptions are true. So it's probably likely that actually the probability of success is higher than a third. So what we conclude is that there's evidence to reject the null. This probability is so low, beneath the 5% significance level, low enough to suggest that the original assumptions are probably not true. So evidence to reject the null. So probably Nazir is correct. He probably has found a way to make the probability of success higher than a third. And that is for the remaining 4 marks in this question. So that's just 7 marks altogether, and the question is now concluded. And if you want to find out more about hypothesis testing or discrete probability distributions, head on over to studyworld.com.